Assalamu alaikum warahmatullahi wabarakatuh. How are you teachers? How are you students? Are you fine? I am Jana Ahmed Abdul Sadiq and today we will talk about chemistry, the magic science. So let us start like a lesson or a topic in chemistry, which is the language of chemistry. We know that the language of chemistry, it's by numbers and by symbols of the elements or for the compounds or another things. So we know that for every element there is a symbol, and for every symbol there is atomic mass, atomic number and the valence number. So today we will talk how to balance a chemical equation. Before that, a chemical equation can be balancing by two methods, which is inspection method and LCM method. But now we will talk about inspection method. So let us start with some examples. First thing, what means inspection method? Inspection method means to balance it by your eyes, without like making a formula or like that. And also after you making balancing by your eyes or by seeing, the atomic number must be the same. Like also there is something about the products and the reactants. That means like for example for reactants and products, that it is, if you want to make H2 plus O2 equal to H2O. Here, this place before the arrow, its name the reactants. And here, after the arrow, it is the product. And I know you that what means balancing, that to be balanced from here and from here. That means the reactant must be the same number of the product to be balancing. Okay? This is the like first thing to know what means reactant and product. That reactant and product in a chemical equation must be balancing. So let us go with some example for inspection method. So the first example, it says magnesium plus oxygen is equal to magnesium oxide. Before here, the first two and also the last two are easy to solve. It is easy to solve because it is written with the symbols. Can you see? But question number 3, it is written by word equation. That means we will change it to chemical equation to solve it. Like for one example, question 3. But first we will solve 1, 2, then we will solve the others. Let us start with the first example, which says magnesium plus oxygen is equal to magnesium oxide. Here first thing, there is one atom for magnesium and here also one atom for magnesium. Here there are two atoms of oxygen and here is only one atom of oxygen. We want to make it balancing between the reactants and the product. So let us, if we add 2 here in front of magnesium oxide, that means will be here 2 atoms for magnesium and 2 atoms for oxygen. That means we're balancing the oxygen. But what about the magnesium? Magnesium here in the reactants, it is 1 atom of magnesium and 2 atoms of magnesium. That means we will add 2 here to make it balancing. Then let us check that they are balancing or no. That make always reactants and products. Here the magnesium and oxygen. Here magnesium it is 2 and here also it is 2. That means 2 atoms of magnesium and here also 2 atoms of magnesium. Here also there's something. Why we know that this oxygen it is like 2 atoms for oxygen, because if the coefficient here, if the coefficient is in front of the symbol, but here there is nothing number or for the subscript there is like any number, or if we say 2 here, like for example if we say 2 here, that means 2 times 2 it will be 4, that means 4 atoms for magnesium. If you want, like if we put subscript here, but what will happen if we put also subscript here? Also we will times the coefficient with the subscript. That means 2 times 2 in oxygen, there will be 4 oxygen. But now here only to be like familiar with the subscript and the coefficient, that if there is a subscript we will times it with the coefficient. So now, as we said before, that the magnesium have 2 atoms, and also here in the products magnesium have 2 atoms. Then in the oxygen there is 2 atoms of oxygen, and also here 2 atoms of oxygen. 2 atoms. Then after that we will collect the total atoms. The total atoms, it is 2 plus 2 4 and 2 plus 2 4, that means 4 atoms. This is the total atoms. So now let us go for the second example. The second example that said lithium plus lithium plus phosphorus is equal to lithium phosphorus. That means here it is not balancing, because lithium, the subscript here is nothing. Can you see? The subscript here there is nothing, but here in the subscript of lithium there is 3, and the subscript for phosphorus it is 4. But here for the phosphorus in products there is nothing also. That means we will make it balanced. So let us go to write the formula. First thing, lithium plus phosphorus, the subscript of 4, is equal to lithium, the subscript of 3, and phosphorus here. So let us to balancing. Here we have 3 and here we have nothing for lithium. If you want to balancing it, we will add 4 here and we will add 12 here. Why I add 12? Because 4 times 3 it is 12. Okay, but why I add 4? Because here, as we said, the coefficient for the 2 elements in front of it. That means the 4 atoms is also for phosphorus. And here what we have? 4 atoms of phosphorus. So that means it is balancing now. That the lithium here in the reactants and here in the products, we have lithium's 12 atoms in the reactants. And in products, we have 3 times 4 is equal to 12 atoms for lithium. And for phosphorus, there is 4 atoms of phosphorus here and 4 atoms for phosphorus in reactants and products. That means the total atoms, it is 16. Okay, it is 16 because 12 plus 4 is equal to 16. This is the total of atoms. Let us go for the third example, which is written by the word equation, and we will change it to chemical equation. So here it's telling propan plus oxygen equal to carbon dioxide plus water. Propan, which is the formula C3H8, propan, because it is from alkanes. Like, I don't want to go for another unit, as we will discuss in another video for the classification of compounds, but I will let you take more informations or some informations about propan. Propan, first thing, it is for 3 because there is methane, ethane, propan, it is 3, methane 1, methane, ethane 2, propan 3, butane 4, pentane 5, hexane 6, heptane 7, octane 8, nenan 9, decane 10. This is the suffix or the prefix of hydrocarbons. So here propan, it's with ane suffix. That means the alkane formula, which is Cn, which means the number CnH2n plus 2. This is a formula for alkane, and here it's telling us propan. That means we will take 3 in place of n. That means C3H2 times 3 plus 2. Of course, 2 times 3 is equal to 6. 6 plus 2 is equal to 8. That means C3H8. The C3H8 is the answer for propan, or the formula of propan, after we make the formula of alkane. So now the propan, which is C3H8 plus what? Plus oxygen. That means plus O2, because O2 it's also from diatomic molecules. The second thing, which is carbon dioxide. That means, of course, we know it, CO2 plus water. And the formula of water, it is H2O plus H2O. Now we change from a word equation. We change now from a word equation to a chemical equation. But here it's not a balancing. They are not balanced. So we want to make it balanced. Here there's something also I want you to focus on. That there are 3 oxygen here. 1 here in the reactants and 2 in the products. But here also there's something that O2 and O2, it's already balancing. From 1 here and 1 here. But the another one in the products, it's not balancing. It's 1 atom of oxygen. But here there are 2 atoms of oxygen and also here 2 atoms of oxygen. So let us how to solve this thing. The first thing, we know that for carbon there are C3. That means 3 atoms of carbon. But here There is nothing. There are only one atom of carbon. We will add 3 here to be balancing with C3. After that, let us go to balancing the hydrogen, which is 8 hydrogen, or 8 atoms of hydrogen. Here it's only 2 hydrogen of hydrogen. 2 atoms of hydrogen. We will put 4 because 2 times 4 is equal to 8. That we balanced the hydrogen. After that, in the same time, we balance the oxygen because the coefficient it's for the 2 elements, for hydrogen and for oxygen, or for water, all. But like in another chemical equations, the coefficient is for the element and for the another element switch behind it. But if there is a plus sign, we can't make like the coefficient for the first element is the same thing after the plus sign. No, it can be like here also. Here, like if we put, for example, 4 here, 4, it will be for these 2, the carbon and for the hydrogen, but it's not for oxygen because there is a sign here. There is a sign, so there is no a relationship between them. So let us forget 4 because it's not from our example. Let us focus here to balancing it. After we find here reactants and products. Reactants, it is the carbon here, 3 atoms of carbon. Here for carbon, it is 3 atoms in reactants. And here in products, there are also 3 atoms of carbon. Here the second thing, which is hydrogen. Hydrogen, it is 8 atoms of hydrogen. And here also, after we times 2 with 4, it will be 8 hydrogen, 4 atoms also. 8 atoms for hydrogen. The second thing, which is oxygen. Here oxygen, to balance it, we have here O2. But first, we have also the coefficient 3. That means here, in place of carbon dioxide, the balancing, the atoms of oxygen now here, it is 2 times 3, 6 atoms of oxygen. 6 atoms of oxygen. But what about here? There is 4 atoms. There are 4 atoms for oxygen. Here, 4 atoms of oxygen. Here there is only 2 atoms of oxygen. We will put 5 to be balancing. How 5? Why 5? Why we didn't put 6? Or why we didn't put 4? Let us to see. Because 2 times 5 it's equal to 10. It's equal to 10. And 6 atoms of oxygen plus 4 atoms of oxygen is equal to 10 atoms of oxygen. That means they are now balancing for oxygen. There are here 10 atoms of oxygen, and here of course we have 6 atoms of oxygen and 4 atoms of oxygen. After we add 6 plus 4 is equal to 10 atoms of oxygen. That means also we're balancing the oxygen, which is 10. After that, let us to find the total atoms. The total atoms, it will be 3 plus 8 is equal to 11. 11 plus 10 is equal to 21. That means the total atoms, it is 21. This is the total atoms for carbon, hydrogen, and oxygen. This was the third example for inspection method. let us go for 4 and 5. Actually 4 and 5 it's not like a hard thing, because you can't I told you before that inspection method you can solve it, you can balancing by your eyes, only by seeing you can balance it. So let us start with the fourth one. The fourth one, which says sodium plus chloride is equal to sodium chloride. So let us start this example. Sodium plus chlorine and also 2 is equal to sodium chloride. That means here first thing, sodium, there is 1 atoms of sodium and also here 1 atoms of sodium. But here there are 2 atoms of sodium, 2 atoms of chlorine and 2 atoms, 1 atoms for chlorine. Because here there is no subscript, there is no coefficient, so that means they are 1. But of course we will not write the 1. That means they have 1. Not mean that if it's written like here without any subscripts or without any coefficients, that means it's like 0. No, there is nothing 0. It is 1. So let us to balancing the chlorine and here the chlorine from products. If we put 2 in front of sodium chloride, that means chloride will be balancing, because it will be 2 atoms of chlorine and also here 2 atoms of chlorine. But what about sodium? There is now 2 atoms for sodium, but here there is only 1 atom for sodium. We will balancing also by saying to put 2 here. That means 2 atoms of sodium and 2 atoms of sodium, 2 atoms of chlorine, 2 atoms of chlorine. So that means we're balancing, and the total atoms of sodium chloride or sodium and chlorine, it is 4, because 2 plus 2 is equal to 4. This like it is a small, like it's a bonus example. Let us go for the 5th example. Also the same for the 4th. The 5th example, it says magnesium plus nitrogen is equal to magnesium nitride. So let us write here the chemical equation, which is magnesium plus nitrogen is equal to magnesium nitride. Here, they are not balancing. Magnesium, they are here in the reactants and in the products. The reactants, there are only 1 atom for magnesium. But here, there are 3 atoms for magnesium. So magnesium is not balancing. How to make balancing? We will put 3 to be balancing, because here is a 3 and we'll put here 3. That means magnesium is balancing now. 3 atoms of magnesium and 3 atoms of magnesium. And nitrogen, there are 2 atoms of nitrogen and 2 atoms of nitrogen. So they are balancing already now. That means 3 atoms of magnesium and 2 atoms of nitrogen for both of them in reactants and products. That means the total atoms of magnesium and nitrogen, it is 3 plus 2, which will be 5. This is the total atom. This is the total atoms. So now we have finished like 5 examples for inspection method. It's only like as we talked before, that it's not only inspection method that we can solve it. It's also by the LCM method. So now we talk about inspection method, but let us talk about LCM method. LCM method, it's also want the valence number of the elements. You need to know the valence number of each element. That means, for example, like valence number between aluminium and oxygen. The valence number for aluminium, it is 3, and the valence number for oxygen, it is 2. After we will crisscross, we'll change it to aluminium 2, because here 2, the valence number of oxygen, it will enter here, and the valence number of aluminium, it will enter here. That means Al2O3. Okay? After that, here, the LCM method, after you finishing, there are also like some elements that have 2 valence number. Like how 2 valence number? For example, copper. There are copper 2 and copper 1. Means copper have 2 valence number. Copper 1 and copper 2. And also iron. Iron 3 and iron 2. Okay? So, let us how to know that here, before to see that how to know that which valence number for the elements that have 2 valence number. Before that, we will discuss how to find the LCM of the first example. We have H2O2 is equal to H2O plus O2. That means we want to change it to to be balancing. That means here the valence number of hydrogen, it is 1. So that means here 2 times 1, it will be 2. Here the valence number for oxygen, it is 2. The valence number of oxygen, it is 2. That means here the subscript times the valence number. That means 2 times 2, it is equal to 4. Okay? Here the hydrogen is the same. It will be 2. The oxygen, which is 2, but there is nothing here, so it will be 2, the valence number of oxygen. The valence number also of oxygen is 2, so 2 times 2, it will be 4. After that, 2, 4, 2, 2, 4. What is the relationship between them? Can we know the LCM for 2 and 4? 2 and 4. So, let us see the LCM of 2 and 4. Of course, 2 times 2 is equal, 2 times 1 equal to 2, 2 times 2 equal to 4, times 3 is equal to 6. Here, 4 times 1 is equal to 4, 4 times 2 is equal to 8, 4 times 3 is equal to 12. After that, we know that the valence number, it will be 4. That means we will take the valence number, which is 4. After we will take 4, here it is a valence number, we will divide it. How? Means to divide it. So, here we have that the H2O2 is equal to H2O plus O2. And we put here 4, here 2, here 2, here 4, and here 2. And the LCM between them, it is 4. That means we will divide for each of the element by 4. That means here, of course, 2 over 4 or 4 over 2. Because don't be confused. 4 over 2 H2O2. We will not divide the second element, which is O2, because there is no sign between them. So that means both of them will divide by 2. Then the next, we will divide also here H2O, which means water. We will divide also all of them by 4 for 2 only. That means it will be 4 over 2 H2O. After that, we will divide also here the 4. That means it will be by 1 plus O2 only. After that, after we divide it, we'll cut by 1 by 2. By 1 by 2. That means the last thing, it will be 2H2O2 is equal to 2 atoms of water plus oxygen. Here we have how to find that is balancing or no. First thing, there are 4 molecules, because 2 times 2 is equal to 4. 4 atoms or 4 molecules for hydrogen. Then here also we have 4 atoms for hydrogen. So that means hydrogen is balancing. Okay, hydrogen is balancing. What about oxygen? 2 times 2, it is 4. That means 4 oxygen. This is in the reactants. Let us see in the products. Here there is no 2, but there is 2, 1. Only 1, 2 for oxygen. That means 2 atoms for oxygen. And here also, there is 2 atoms for oxygen. So here in the products, we have 2 oxygen and 2 oxygen. After we make plus, it will be 4 oxygen. And here we have already 4 hydrogen. That means, and here also 4 oxygen. And here 4 oxygen and 4 hydrogen. That means they are balancing. After they are balancing, we can find the total atoms for all of the atoms. That means it will be 4 plus 4 equal to 8. 8 atoms. The total atoms, it is equal to 8. This was the first formula, and it was with adding also. We take the process of adding because there was 2 oxygen. And we added. After that, after we added, we will take 4 oxygen and 4 oxygen from the reactants, 4 oxygen in products, 4 hydrogen in reactants, 4 hydrogen in products. So they are balancing. Let us go for the second example, which there will be iron. So iron, here, iron. We know that iron, it have valence number 1 and valence number 3. Or valence number 2 and valence number 3. Or we will discuss only in valence number 3. Why? Why we choose valence number 3? Because here, if you see in the products, there are 3 for oxygen, or the valence number of iron. The valence number of iron. Because here it's already given by the crisscross method that iron have the valence number of 3, oxygen has the valence number of 2. After that, after we crisscross, we will take the same for Fe2O3. That means it's already here being with the crisscross method. But here Fe plus O2 is equal to Fe2O3. We want to balancing both of them, the reactants and the products. So that means the valence number for iron, it is 3. Okay, the valence number for oxygen, of course we know that it's 2, so 2 times 2 is equal to 4. After that, the valence number for iron, it is 3. 3 times 2 is equal to 6. The valence number of 2 is equal, for oxygen is 2. Then 2 times 3 is equal to 6. After we have 3, 4, 6, and 6, we will take 12 for the valence number of 3, 4, 6. That means the LCM of 3 and 4 and 6, it is 12. Because 3 times 4 is equal to 12, 4 times 3 is equal to 12, 6 times 2 is equal to 12. So let us divide it and to see that they will be balancing or no. So iron has a valence number 3 here plus O2, which means by 4, and here it will be 12, the LCM, Fe2O3, and here it will be 6 with 6. We will take 1 6 from them. That means it's the first one here. So it will be 6 over, 12 over 6. Because 1 over 2, it will be repeated to 2 over 1. That means 12 over 6 Fe2O3. Here we will divide also 12 by 3 and 12 by 4. Why we will divide also by 4? Because there is a sign. I told you that if there is a sign, that means we will divide the element also here. So that means it will be 3 12 over 3 Fe plus 12 over 4 O2. After that, we want to divide it and to see that they will be balancing or no. By 1, by 4. By 1, by 3. By 1, by 2. Then the next example, it says aluminium plus oxygen is equal to aluminium 2O3. That means how to make aluminium and oxygen balance in reactants and products. So let us first to know what is the valence number for aluminium. It is 3. The valence number for oxygen, it is 2. That means 2 times 2 is equal to 4. Then aluminium, we know as before, the valence number is 3. That here the subscript have 2. That means 2 times 3 is equal to 6. And here 3 times 2, because of the valence number of oxygen 2. 3 times 2 is equal to 6. What is the LCM in 3, 4, and 6? It is 12. The LCM for 3, 4, and 6, it is 12. That means divide 12 in aluminium, oxygen, and aluminium 2O3. First thing, we will make 12 over 3 aluminium plus 12 over 4 oxygen is equal to 12 over 6 Al2O3. After that, we will cut by 3, 4, by 4, 3, by 6, 2. So that means 4 aluminium plus 3 O2 is equal to 2 Al2O3. Then let us to see that it is balanced or not. First thing, here there are 4 atoms for aluminium, and here also there are 4 atoms for aluminium, because 2 times 2 is equal to 4. That means aluminium, it's balanced. Then the oxygen, there are 3 times 2, 6 atoms of oxygen. Here 2, because 2 is the coefficient. Then 2 times 3 is equal to 6. That means 6 atoms of oxygen. They are balanced now. 4 aluminium and 6 atoms. And after you will add the total atoms, it will be 10. That means to be balanced. Whatever it is LCM or inspection method, we can balance it by inspections that by seeing you can it is error also. It is like error things that maybe it will not come with you easily if you use the inspection way, but also like it can be balancing by the inspection method. But LCM method wants the balance number and also to memorize balance number. But before I was telling today about the balance number, don't forget the balance number of iron, of aluminium, and other things. But do you know about what means valence number? Valence number is the combining of an element. Don't forget about the valence number. For each element there is a valence number. And also some elements can be for two valence number, like iron or like copper. So I think you understand how to balancing a chemical equation whenever it's LCM or inspection method. I hope that you understand how to balancing a chemical equation, like from a word equation. After, if it's given a word equation, you will change it to a chemical equation. Then you will solve it. Then you will make a balancing. I think now how to balancing a chemical equation by two ways or two methods, which is inspection method and LCM method. That means don't forget about inspections that you can like solve it by your eyes or by saying it, and LCM that can be solved by the valence number. Okay, so I hope that you understand from this. And I hope that you benefit also from this topic. And thank you for your time, thank you for listening, and thank you for watching. Goodbye and see you another time.